Hey there, welcome back to this video on solving logarithmic equations algebraically, and this is part 2 of the lesson. In this lesson, we're going to look at a different type of solving logarithmic equations when we're posed with a certain problem, and I'll go ahead and introduce that problem here. This says, explain why it's not possible to use the property of equality for logarithms to solve the equation log base 7 of x minus 3 is equal to 2. Well, the property of equality for logarithms says that if I have a single logarithm on both sides with the same base, then I can go ahead and remove that. But in this case, notice how I only have one logarithm on the left side and I don't have one on the right. Well, then I can't use the property of equality to remove the logarithm. So what we're going to have to do is we're going to have to go about this a different way. What we're going to do is we are going to have to switch from logarithmic form to exponential form. And you can see here's an example. Log base b of x is equal to n. Again, that's logarithmic form. Now remember, I can go ahead and rewrite this or find the inverse just by switching to the equivalent exponential form, which is x is equal to b to the power of n. So I'm just going to adjust the steps for this a little bit. We're still going to use the properties of logarithms to write it as a single logarithm on one side. There will be a numeric value on the second one. And then what we'll do is we'll go ahead and rewrite it in exponential form. So here is the the shift. Remember, we have log base b of x, where x is your argument, okay? And this is equal to n. Remember, inputs and outputs switch, and your base stays the same. Okay, so notice log base b of x is still b, base b, and then inputs and outputs switch. So it's b to the n is equal to x. Step 3, we'll solve using algebra. And then step 4, check for extraneous solutions. Again, we have to check and see, is the argument of the logarithm positive? Let's go ahead and look at an example. Here we have log base 2 of x plus 5 minus log base 2 of 6, and this is equal to 3. So step 1, I'm going to go ahead and write it as a single logarithm. So I have log base 2 of, and I have x plus 5 divided by 6, right? We're subtracting, so we'll go ahead and divide, and this is equal to 3. Now, notice, I can't go ahead and, cancel logarithms on each side. So step 2, here's where I'm going to switch to exponential form. I have 2 to the power of 3, right? Base stays the same, inputs and outputs switch, is equal to x plus 5 over 6. And that's it. If I don't cancel the logarithm on both sides, I have to get rid of the logarithm somehow, and so we just switch to the exponential form. Okay, so this is equal to 8, which is equal to x plus 5 divided by 6. So we'll go ahead and multiply both sides by 6. We get 48 is equal to x plus 5. And I'll go ahead, subtract 5 on each side to give us our solution. X is equal to 43. There you go. Okay, we do have to check. I want to go ahead and check. So that was step 3 using algebra. Step 4, we got to go ahead and check. So if I plug in 43 into my original arguments here, 43 plus 5, that's 48. It's still positive. So there's our solution. X equals 43. Again, if it gives you a negative answer, that's when you would toss it. Okay, here we go. This time we have the common log of 3x plus 1 is equal to 2. Okay, I have one logarithm on the right side, so step 1 is already done. Step 2, I'm going to go ahead and switch to exponential form. I can't reduce the logarithm on either side. I only have one. So I'm going to use the base. Here's a question. What's the base of a common log? 10. Very good. So 10 to the power of 2 is equal to 3x plus 1. Okay, so I'll go ahead and solve. I'll subtract 1 on each side. and we get 99 is equal to 3x. We'll divide by 3 on each side. And we get x is equal to 33. Okay, I'll go ahead and check it. If I plug in 33 here, 3 times 33 is 99, plus 1 is 100. We are good. There's your answer, x equals 33. Pretty simple, right? Pretty simple. Okay, here is a practice problem. Please go ahead. Give this one a go. Okay, hopefully you pause the video. Here is the solution. You need to multiply the arguments on the left side to give you 3x plus 21. I can't cancel a logarithm each side, so I switch to exponential form. 9 to the power of 2, which is 81, is equal to 3x plus 21, which gives us 60 is equal to 3x, yielding an answer of 20, which works out. So there it is. All right, here is, I believe this is the last example that I have. Natural log of 2x minus 1 is equal to 6. So in this case, again, I have a single logarithm on each side. I'm just going to go ahead and rewrite it in exponential form. This is e to the power of 6 is equal to 2x minus 1, right? Natural log, the base is e. So e to the 6 is equal to 2x plus minus 1. In this case, I don't have a calculator. They're wanting the exact solution. It doesn't say anything about approximation, so I'm not going to worry about what e to the 6 is. I'm just going to leave it. I'm going to leave it as e to the 6, and I'll add 1 to each side, giving us e to the 6 plus 1 is equal to 2x, and then I'll go ahead and divide by 2. So we get x is equal to e to the 6 plus 1 divided by 2. Okay? And in this case, if I go ahead and plug it up here, this value is positive here, e to the 6 plus 1. So if I go ahead and plug it in, we're going to get a valid answer. It is positive. Okay. Here you go. Please try this example. Okay, hopefully you pause the video. Here is the solution. We get x equals e to the 4th divided by 9. That is the solution. There you go. And here is the last practice one. Please pause the video. Give this one a try. All right. In this case, we ended up with a quadratic. We had x squared minus 9x. And if we rewrite this in exponential form, we get 10 to the power of 1 is equal to x squared minus 9x. Bringing that 10 over, we can go ahead and factor. And in this case, when we plug in -1, which is one of our possible solutions, that is a negative argument. Got to throw it out. So the only answer here is 10. All right. So closure, wrapping up this part of the lesson, explain when you must use the property of equality for logarithms and when do you use the exponential form. Two different types of solving. When do we use the property of equality? When do we switch to exponential form? And hopefully you answered, you use the property of equality when you have a logarithm on both sides. You switch to exponential form when you only have a logarithm on one side. That's going to do it for this lesson. Hope you're doing well. Take care. See you next time. Peace.